Hello, everyone. Good morning, good afternoon, or good evening. The authors, distinguished session chair, and invited guests. Welcome to Technical Session 7E. I'm Sanskriti Khamkar, and I will be moderating this session today. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to 11th International Conference on Information and Communications Technology for Sustainable Development, that is ICT4SD 2026, in Goa, India. The 11th edition of the conference is being conducted in a hybrid mode. The physical conference was held yesterday in Goa, while the virtual conference is being conducted via Zoom from 9th to 11th July 2026. I hope you enjoyed today's informative and engaging technical presentations. In this session, we have 10 paper presentations. Each presenter will be allotted 10 minutes for their presentation, followed by 2 minutes for Q&A. At the 8-minute mark, I will give a gentle reminder so that we can maintain a schedule. I also request all participants to stay connected with us until the closing remarks. If you have any questions or require any assistance during the session, please feel free to send me a message through the chat. Now, before we begin, it is my privilege to introduce the session chair for this session. Dr. Suvarna Patil is an associate professor at D.Y. Patil International University in Pune, India. She brings 18 years of teaching experience and specializes in networking and Internet of Things. She's committed to academic excellence, impactful research, and fostering innovation in emerging communication technologies. We're honored to have you here, ma'am. Would you please like to start this session with a few words?
Good morning, all of you. So thank you for giving me the invitation as a session chair. So I would like to say all the best to all the participants. Okay, you can continue the session.
Thank you for your encouraging words, ma'am. So, and now we will begin the presentations. First, we have David Eluathingal presenting the paper titled AgroShield: Disease Detection in Cotton Crop Using Machine Learning and Image Processing. David, you may start your presentation.
Yeah. Is my screen visible?
Yes.
Good morning, everyone. This is my presentation of AgroSeal, disease detection in cotton crop using machine learning and image processing. My team members are Gia, me, Priya Paul, and Professor Priya Kaur. So the outline of today's presentation will be introduction of the problem statement, objectives, the scope of the project, requirement gathering, system architecture, evaluation metrics, societal impact, and references. The problem statement. As we all know, India is one of the leading countries in the production of the cotton crops. Many of the farmers and the citizens are dependent upon the yield of the cotton crops, and this yield is affected by many of the diseases in the cotton crop, and predicting it at an earlier life cycle of the disease is very essential. For this purpose, we have created AgroSeal. AgroSeal is an AI model, a CNN-based AI model, which is used to predict the diseases in the cotton crops. After it has been detected using the HSV based method, we are finding the severity of it and using and giving the farmer the treatment guidance or the pesticides to be used so that it can be prevented furthermore. The scope of the project is data collection, model development, and deployment. In data collection, along with my teammates, went to a place called Parbani in Maharashtra. so that we can collect on-field data about the healthy and the unhealthy cotton crops. Then using Python, we cleansed it, labeled it properly, and using data augmentation, created more samples so that the model can be trained with a high number of samples. Then finally, we integrated this model with a user-friendly interface with multilingual support so that the farmers can interact with it properly. The literature survey. Uh, we went through all the most of the research paper, which was mostly which has a number of citation right from 2018 to 2023. We saw that the most of the papers were achieving high accuracy with the help of CNN model, SVM, or the random forest model. Keeping this in mind, we have created our model. Coming to the coming to the requirement gathering, the images data used for this model was generally taken from the field site to visit from Perpani in Maharashtra. We cleansed it using Python, labeled it properly, and using data augmentation, we created more samples so that the model can be trained. Similarly, as I told, we created the user interference. The system architecture of the model. We used a CNN model. It has five convolutional neural blocks with filters ranging from 32 filters right till 512 filters with dropout layers in between so that the overfitting can be prevented. And for optimizing and finding the gradient, we used Adam with a learning rate of 10 raised to minus 4. Furthermore, after predicting the result, we did the severity calculation. The formula of severity calculation was the area of the infected leaf area upon the total multiplied by 100. And based on one of the official documents, we are providing them with the recommended pesticides uh, uh, or the treatment plan necessary. Now coming to the evaluation metrics, we had a 95.72 training accuracy and a testing accuracy of 91.08 accuracy. And this is our other metric, confusion metric graphs, and this is uh, uh, the um, prediction result of our software. Societal and research impact. Uh, Detecting the disease at an earlier stage helps the farmer in taking a preventive care and increasing the yield of the crop of the cotton crops, which will in turn help in economic benefit and bring more profits to the farmers. This is my references. Thank you.
Hello, am I audible?
Yes. Yes, ma'am.
In your system architecture, you have used CNN model.
Yes, ma'am.
Okay, you can just go
Yeah.
through that system architecture.
Yeah, I will screen share once again, ma'am.
Yeah.
Is it visible?
Yes, yes.
Yes, ma'am.
You have shown here that VCG 16 you have used, okay, and Inception V4. So can you just elaborate on this, what VCG and why you have used VCG here, why not VGG?
It is we are not using it. We are just written all of these models, so we are comparing it with our model. The VCG, Inception, V4, and ResNet are all like CNN based model. which does this similar work. But the model that we have created are from scratch with convolutional neural blocks and everything. We are not using any pre-built model or
So
something.
then why you have used in the system architecture? If you are not using, you
It
are just
is
comparing, right?
it is for comparing with the result in the research paper we have done it, so that's why we put it.
Is it a review paper here? You have not implemented?
We have implemented it. I show you the result. Our
Okay, it's okay, no issue. What is your data set?
data set is about 4,000 plus images.
How much?
4,000 plus.
4,000. And how much data set you have considered for training and testing?
It is 80 10 10 we have kept.
Okay, and the optimizer which you have used?
Adam optimizer.
Okay, fine. How you have calculated the severity level? What actually that defines what you are calculating in that?
Then severity level is basically the infected region of the leaf and upon the total of the healthy part of the leaf. And based on it, we are finding the percentage. And there is one document which was provided. We are using it and then giving the pesticides or the nutrient based like copper based nutrients or sulfur based nutrients so that it can be prevented like bacterial bite, virus or fusarium wilt, etc.
Okay. Can you just tell me that ReLU function and the softmax activation, what does it do actually?
Relu function is an function that what we say if any negative value is there, it makes it into zero and only allows the positive values to be considered. And
But
soft max
what negative value represent as you are saying that what it considers then? You have
the
your data
few
set from that when the ReLU function will activate, then what happens? That I need.
and the few of the values after the features that are being collected, if few of the like HSV images and the features are negative, it will then calculate it if it is negative, as it has nothing of value, it will consider it as zero.
What does it
And
mean? Zero means what? What exactly?
zero means that it is nothing of what is it is specialist there. There is no feature about any of the diseases.
Okay, it's okay. Thank you. Yeah.
Yeah.
Thank you for your presentation. Now we have Anjali Babar presenting the paper titled Cardiac Disease Prediction Using Deep Learning Model.
Good morning, everyone.
Good
This is
morning.
my topic for presentation, cardiac disease prediction using deep learning model. So one second. So the abstract for it is the projector represents that I have used SDC dataset for the project, which works on the MRI images, and it creates I have used a vision transformer model for the feature extraction, and which involves ED and ES feature fusion. As an input, and it will give the five classifications, which are the NOR means normal, myocardial infarction, dilated cardiomyopathy, hypertrophic cardiomyopathy, and abnormal right ventricle. Uh, these are the contents in the presentation. Introduction: cardiac disease is a very major cause in the for the death in the worldwide. So early prediction is required for the earlier diagnosis, and to analyze the cardiac disease and provide the faster and accurate cardiac disease diagnosis. With the help of vision transfer model, we can extract the important features and also accurate features as compared to traditional methods. It is it becomes very beneficial for the patients also and for the doctors also to diagnose for early diagnosis. These are the five divisions as I have mentioned. First one is the NOR. I will first explain these five divisions. NOR means normal, means heart pumps the blood throughout the body very efficiently, and there is no issue. And second one is the myocardial infarction. This is the condition of the heart where the blood flow to the part of the muscle get blocked, and that causes the heart related disease. Third one is a dilated cardiomyopathy, in which this is the condition of the heart where the heart muscle the chamber of the heart become abnormally long or thin. As the chamber becomes thin, it wall of the chamber becomes thin. It becomes very hard to pump the blood. This is the condition where the cardiac disease can cause. And fourth one is a hypertrophic cardiomyopathy, where the wall of the chamber become abnormally thick. So it becomes hard to pump the blood and supply the blood to the throughout the body. So this is the fourth condition where it causes the disease. And fifth one is the abnormal right ventricle. Means the right ventricle becomes abnormal as compared to the left ventricle. Whether it is the structure of the chamber becomes different, or the working of the right ventricle becomes normal. So this is condition where abnormal right ventricle. Fifth condition. Then literature review. I have used this literature review from 2021-25. These are the early papers. Objective is to study various cardiac disease detection and classification method using deep learning techniques. And it also and if to develop the effective image processing and feature extraction method from the cardiac MRI dataset, and develop the deep learning model using the vision transfer model, and give the accurate prediction and classification. This is the method for the project. First, I have used the MRI images as an input, where after that we will use the we will pre-process that images. There are two different structures for that pre-processing, means ED and ES. ED means end diastole and ES means end systole. ED is the situation where the heart is means there is a very less amount of blood in the heart, and ES is the situation where blood is where heart is full of blood. So these are the two different situations of the heart, and these two images we will combine for our vision transfer model to give as an input, and we will resize it into the 224 pixel for as it is required for the vision transfer model. And after that we will do the classifications, and it will give the output as an NOR, MINF, DCM, HCM, and RV. These are the methodology. First, as I have shown in the figure also, data acquisition means we will use the ED and ES scans. In second, we will do image processing. Means we will resize the MRI image into the 224 by 224. And third one is a vision transformer. So it will combine the ED and ES images, and helps to model learn the cardiac structure. And fourth one is feature extraction, where we will use the means we will calculate the cardiac features and represent. We can identify the structure as and for fifth one is a classification where we will use the 5 level of classifications as an output. So we will get the output in the and also the accuracy with the help of the um, uh, precisions and recall also. These are the results of the um, model. There are two conditions. First one is a slice level, and second one is a patient level. Patient level in patient level classification, we will use the one by one images as an input, and in the slice level classification, all the 9 images becomes we will supply 9 images as an input, and it will calculate. It will do the model will do the prediction based on the prediction based on the loss. We will calculate the we will update the loss function, and it will improve by means improve the improve the accuracy by its own. So these are the two conditions. Vision transformer model works on the patches. It's not work on the pixel. So one word becomes 14 into 14 into 14 pixel becomes the one patch. So it gives text input as an patches. So it becomes very useful for the early predictions. Conclusion, the project so this project will use the deep learning model techniques, and I have used a ACDC dataset for that, and it will use it for feature extraction and classification accuracy, and it also reduces the manual feature engineering and improves the cardiac diagnosis accuracy. It results the high performance and making the system useful for early and reliable detection. Future work is to use the advanced architecture like ResNet and DenseNet, and also 3D processing. These are the references. Thank you.
Hello.
Yes, ma'am.
Why you have used 16 by 16 patches in Vision Transformer?
It is the requirement of the vision transformer model, where I have where we can pre-process the ED and ES images and combine them into the in that format for 16 by 16 format. Means it is required 224 pixel is the size requirement for the model, so that's why I have used that.
Okay. So have you compared with your model with the previous models existing
Yes, ma'am.
system? What are those?
Yes, ma'am. Like in CNN model, we use as pixels only, and in vision transformer model we have used patches. So the accuracy of the vision transformer model becomes as I have shown in the figure also. The accuracy is about around 94%. So this is more accurate than the traditional CNN model. So vision transformer model is very better than the traditional methods.
What is the data side and what are the data set you have taken for this cardiac?
Dataset is ACDC dataset, where there are patients, there are around uh, above 100 plus patients records are there. Each patient records having the two different MRI images. First one is ED images and second one is ES images. This data set is taken as an input. That's it.
Okay, thank you.
Thank you, ma'am.
Thank you for your presentation, Anjali. Now we have Vaishnavi Darvi presenting the paper titled Claim Sage, an agentic RAG framework for deep reasoning over insurance claims.
Is my screen visible?
Yes, it's visible.
Good morning, one and all. I, Vaishnavi Ramesh Dalvi, would like to present on the topic Claim Sage and Agentic RAG Framework for Deep Reasoning over Insurance Claim. Current insurance systems are highly fragmented, where policy services, billing, claim management, and customer support operate as separate models. This results in delays, repetitive verification, and poor customer experiences. Another major challenge is claim verification, where uh, manual inspection of vehicle damage images is slow, and traditional rule-based system fail to detect fraud claim patterns. Also, chatbot solutions are limited to complex multi-domain queries. Therefore, there is a need to develop a unified intelligence system that combines multi-agent insurance system, retrieval augment reasoning, fraud-aware claim verification, and customer assistance within a single framework. This research aims to address the gap through the ClaimSage framework. The primary objective of this project is to develop a multi-agent insurance system that is capable of handling policy inquiries, billing support, claim processing, and general customer assistance within a single framework. To improve the response accuracy of policy related questions, we integrate retrieval augment reasoning RAG with domain specific knowledge documents. Another objective is claim verification using a deep learning model to analyze the vehicle damage images. To improve the transparency and observability of the multi-agent workflow through monitoring and tracing mechanism for agent interaction and decision flows. The proposed system for a claim sage is a unified AI-driven insurance support framework that combines a supervisor agent, specialized multi-agent architecture, RAG-based policy assistance, fraud-aware claim verification, structured database integration, workflow automation and human escalation, and lastly, monitoring and observability. System architecture. This is the overall system architecture for AI supported insurance support system. This is a multi-agent architecture with central supervisor agent which coordinates with the entire system. When the user sends the query or a claim image, the supervisor agent gets the notification. The supervisor agent analyzes the intent behind the query or the the supervisor agent analyzes the intent, analyzes the communication history, and routes the query to particular specialized agent. If the query is related to policy information, it is handed to policy agent. Simple queries such as deductibility or regarding policy information, the information is retrieved from SQLite database. And for complex query, we use RAG architecture. In this process, in the RAG process, the information is retrieved from ChromaDB and handed over to the LLM, which generates the final response. If the query is related to the billing agent retrieves the information from the SQL database. The information can be what is the amount, billing amount. If the query is related to the claim agent, the claim agent handles structured data as well as claim image. If the query is related to the structured data, the data is retrieved from the SQLite DB. And if the query is related to the if the query is image, so for image detection, we are using a convex tiny deep learning model which predicts whether the image is fraud or not. On that information, we combine the information along with the policy details and generate a final score. On that score, we decide whether this claim should be processed or it should not be processed. Third, if the query is related to general help agent, like asking, if the query is related to the general help agent, it retrieves the information from the ChromaDB over insurance QA dataset. Finally, the final answer agent retrieves all the information and generates a final response. If all these agents are unable to describe or unable to solve the query of the user, this query is handed over to his human escalation agent. Results. This slide shows the performance comparison of deep learning models on fraud detection dataset. From this 5 models, we clearly get to know that ConvNext model outperformed from the rest of the models, getting an accuracy of 98.58% and recall of 99.92%. On this information, we can say that ConvNext model is accurate to detect fraud image detection. Conclusion. Proposed claim Sage, a unified multi-agent insurance support framework. In this, we integrated RAG structured database access and fraud-aware claim verification within a single platform. Through the deep learning models, we got to know that ConvNext achieved 98.58% accuracy and 99.92% recall, demonstrating the effectiveness of the proposed approach. That's all. Thank you.
What specific RAG vector database of frame handle the policy assistance?
Ma'am, can you repeat the question?
What specific RAG vector database or framework handle the policy assistance?
Ma'am, here the policy agent is dealing with the policy related information. In that, we have used the RAG architecture. For in the RAG architecture, we have used MetaLlama 8B model for the embed as an embedding model, and for the uh, for other two models are after for chunking, we have used all mini LM version 6 model for chunking. Ma'am, these two models we have used in the RAG architecture.
Okay. How does the supervisor agent coordinate tasks among the specified agents?
Ma'am, as this is a multi-agent architecture which is built on a lang graph, so for the supervisor agent, we write the prompt and we give in detail information about how each agent and what all each agent will give the information. Through that, the supervisor agent gets to know that this query is to be routed to the particular agent.
Okay, thank you.
Thank you, ma'am.
Ma'am, do you have any questions? Okay, I think that are all the questions. Thank you, Vaishnavi, for your presentation. Now we have Dhaval Shah presenting the paper titled Cloud Independent Multi-Sensor Anomaly Detection Using TinyML.
I hope my screen is visible.
Yes, it's visible.
Okay, good morning, everyone. I'm going to present a paper on title Cloud Independent Multi-Sensor Anomaly Detection Using TinyML. Along with me, my student Sakshi is there in this particular task. So the motivation behind this work is because nowadays many systems today dependent on internet and cloud to process the data. And as you know, when you process the data over cloud, it will take a time. Certain data which are very less and easily can be detected on a board, and we are having a low cost low power intelligent boards are also available nowadays. So our approach was to implement this system over the edge devices. So the overall objectives are to study the what are the method to anomaly detection with a multi-sensor system, develop a tiny ML based model preparing processing multi-sensor data for the training and deployment, and to design a real-time cloud independent system. So the outline of the presentations are this. So I will start with a brief introduction about our system. Is that our system include of input sensors that are accelerometer, temperature sensor, light sensor, which is available on this particular board called Arduino Nano 333 BLE. And on that board itself we have trained ready-made train our trained model will be available, that it will detect whether anomaly is there or not. That is what the final output of this work. So if we see the literature review till date, I have put only few recent paper with that. So first paper is using auto encoder based TinyML approach for real-time anomaly detection. Here in this particular paper, author has considered only single sensor for the same, use auto encoder approach, similar approach what we are going to use in our implementation as well. Similarly, second case, they have used feature extraction plus k-means and auto encoder. But the evaluated on limited sensor type. Again, the number of sensor is one or two only there. And if you see this way, all the available literature paper, they focus only energy efficient sensing, considering only one or two particular sensor in this paper number 3 and paper number 4. So the clear research gap, what I want to convey over here is major of the existing work focus on a single sensor anomaly detection, and they have a very limited cloud independent tiny ML implementation, and also their lack of integrated multiple sensor, as I said before. So we need to have the lightweight real-time anomaly detection system with under resource constraint and microcontrollers. So in our particular system, what we do that we are having a board which is having all three inbuilt sensors. So sensor will be giving the data which is continuously recorded under the normal operating conditions to create a training data set for the encoder auto encoder model. Then it will be pre-processed for clean and normalized to ensure that uniform scale, improving accuracy and stability of the model training. Then model prediction will be happen with the trained autoencoder model, and then error calculation will be carried out, and then whatever results come, it's going to compare against the threshold, and based on that we decide whether anomaly detected or not. So for this tools and technology, the programming language we use C, C++, and Python. For Google Colab development, we use Arduino IDE. Machine learning platform, Google Colab, we have used. ML framework, we use a TensorFlow and TensorFlow Lite, because they are the tiny ML compatible model for training and lightweight embedded deployment. And data processing, we use a NumPy and Panda. And model type, we use autoencoded neural network model. So if you see the implementation stages, the first stages, we are training the model on the first graph here. Next, calculating a threshold value and then converting a T-flit model. Finally, we upload that model into H file, and if you find that the right hand side, the graph is giving the epoch versus losses. So if you see the blue line, that is the losses while we are training the model, and later on the orange line, we're showing the validation losses while we are doing the real-time running. So we almost after 60 epoch, almost the loss is going to be stable over there. So we normally use more than 250 training samples, and for testing we use a 17 to 80 in together. So these are the projects, and these are the sample snap of the normal condition scenario, lighting condition scenario, under heating as well. So I'm going to play a little video for that. So now if you see that this is the entire structure where the Arduino BLE3 is available. Now we are checking in normal condition as well as the, if something goes wrong, right, when we moving the board, then anomaly is going to be detected. So that will be seen over here. So now we are moving board so that will be detected. Similarly, we have carried out for all the three other sensors, and towards the end you will see another sensor as well. So similarly, we have carried out for a light sensor as well. So this is a normal condition, and now when we are changing the scenario, it happens. So this way we have implemented entire anomaly detection method for considering these three sensor in a single model, and this model successfully detect the anomaly using a sensor data. It takes the real-time data from accelerometer, temperature, light sensor, and the demonstration already has been shown in the PPT as well. TensorFlow Lite model is used to identify abnormal pattern based on a reconstruction error, and the system effectively distinguish between normal and anomalous conditions. So this the further work can be done out what we are trying it. We can still improve the accuracy of this particular model, and we can add more sensor for the on the same board itself, and these are the references. Thank you.
What specific type of sensor are included in your multi-sensor systems?
Specifically temperature sensor, accelerometer, and light sensor.
Okay. TinyML device has server memory limitations. Okay. How will you handle data windowing or pre-processing within those constraints?
Yeah, at this model, all the pre-processing and everything we have done offloaded. We just deploy the trained model, and in future work, we also going to see that within that memory constraint, how we can look for. That is going on work, so, ma'am.
Okay. Hmm. How will you optimize the model size to fit into the limited RAM and flash memory of the embedded system?
Yes, currently we are just using a three sensor data, and when we do everything on over a Google Colab, we are getting the trained model within the size of the memory. So currently at the beginning stage, we only look at the whatever the board memory size, and according to that, we restrict ourselves for training and validation, and that's how we manage it.
Okay. Uh, what is your accuracy in this project?
Sorry, ma'am, can you repeat it?
What is the accuracy for this project?
Okay, currently we have got accuracy somewhere around 93-94%, but our training sets is also less or almost very less, and testing is also slowly we are going to incorporating more sensor as well as the training as well. So this is the beginning step. That's why
Okay.
we are getting 90 odd one.
Okay. Okay. Thank you.
Thank you, ma'am.
Thank you for your presentation. Now we have Rahul presenting their paper titled Comparative Analysis of Machine Learning Models for Alzheimer's Disease Prediction Using Correlation-Based Feature Selection. Rahul, are you here with us? Rahul, are you here with us? Okay, so we'll be moving forward with our next presentation. Our next presenter is D. Kishore Babu presenting their paper titled Customized Crop Solution for Farmers Considering the Soil and the Climate. Kishore Babu, are you here with us? D. Kishore Babu, are you here in the session? We'll be going forward with the next presentation. Now we have Sachin Gajjar presenting the paper titled Design and Verification of the 8085 Microprocessor Using Verilog HDL.
So I am there. Can you just give me the rights for sharing the screen? Hello, am I audible?
Yes, you're audible. So just try sharing again.
Okay, okay. Okay, is my screen visible?
Yes, it's visible.
Okay. 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 How do I have this pane also go away this? Anyway.
What's
Okay,
the
done.
problem?
Yeah, done. Am I clearly audible and is my screen visible?
Yes.
Okay, okay. So, good morning to all of you. our work is design and verification of 8085 architecture using Verilog, and this has been done in collaboration with Dhruv and Professor Viranji Pandya. And Dhruv is there along with me for taking a part of this presentation there. So we are going to discuss the introduction related to our work, then the literature review that we have done, then whatever work that we have proposed, the tools that we have used for the implementation purpose, then details about how we have implemented this architecture, then finally how we tested it, and then we will conclude. So basically 8085, as we know, is an 8-bit microprocessor developed by Intel, and it was the one that had revolutionized the computing, and there were lot many foundational concepts that we could understand based upon this microprocessor. So we picked up that and we just tried to initially work upon tweaking it based upon our requirements. So this is the first phase of our implementation, whereby we have just tried to mimic this entire architecture there. So basically we targeted upon developing the ALU, register file, memory interface, instruction decoder, program counter, control unit of the 8-bit microprocessor. So we had the RTL design for this. We integrated all of these modules, and then we had a code, the test bench written in order to check this architecture there. So, so for this, we did some initial review there. So in the review, we majorly found that as such, there is no formal modular implementation of 8085 architecture there. So once if we have got a modular implementation, then we can have kind of change the blocks based upon our requirement, and then we can have our own piece of processor which is based on 8085. So we designed and verified the 8085 architecture using Verilog HDL, and our functional blocks mainly included ALU register file memory and the control unit as well as the instruction decoder. We implemented the FSM based fetch decode execution module, which is the heart of the system, in a successful way. And then we also developed a self-checking verification code there, so that we can automatically check and validate the processor that we have developed there. The tools that we used included Xilinx Vivado, and it is a kind of a primary design suite accepted by industry also, given by Xilinx, and QuestaSim was typically used in order to do the functional simulation, debugging, as well as verification. So if we talk of 8085, it's a von Neumann architecture, so that whereby the memory space is shared for program and data memory. It is typically 16-bit address bus is there, 8-bit data bus is there, and the register set consists of general purpose registers as well as the accumulator and the program counter to keep the track of next instruction to be executed in stack pointer pointing to the top of the stack. Our architecture works on 3 megahertz clock speed, and typically 5 volt is the signal power supply that is required for its operation. So these are the major instructions that we have implemented in our architecture, and we tried to initially cover the arithmetic and logical instructions because we targeted onto ALU implementation there. So from now, from this particular slide, I'll request Dhruv to take it further. Dhruv?
Yeah. Am I audible?
Yes, you are audible.
Yeah. Okay. So hi everyone, myself Dhruv. So here we started from the ALU checker flow. Basically, our motto is to thoroughly verify the whole design, block by block. So what we started with, initially we have test vectors like input. ALU has two inputs, one opcode. Opcode means what I need to do, add, subtract, multiply or something, and the carry input. So first of all, what we did, we have created a two different models. First is DUT. DUT is nothing, just a design under test. That is a main ALU. And right side, if you see, there is a reference model. What I have did in a test bench only, I have created checker logic. Checker logic, what it does, let's say I have initiated a add operation through the ALU. So let's say add operation where input is 5 plus 2. So it becomes 7. So I will pass on the reference model a 7 expected data. What should I get a expected data as a 7? And the same input I will pass through the ALU design. If both expected output and my actual output will be compared at the end. If those are matched, it means our design is working correctly. I can ensure that my design is working correctly. Likewise, I will add the checker and expected actual output for each inputs. So we are moving on the next slide. So here we can see in a waveform, I can highlight that first A and B are the first inputs, and opcode, the 4-bit of opcode is there. It will say whether my operation is add, and or what. So first of all, 18 and 52 data is there, and here we can see opcode is 0. 0 is nothing but add without carry. So without carry, it's a 255. It's a hex number, so it sorry, 70 it will give output as add operation, 52 plus 18. And then next, moving on to the next data, it's uh, no sir, sorry, previous slide. Yeah, in the 240 plus 15 with opcode 1, and opcode 1 means with carry we will add. So with the carry, it will says 255 plus 1. So it means it goes out of the beyond 8-bit. That's why it goes to 0. So here waveform will be little bit hard to be see. So I have created a checker in the next slides, we can say. Yeah, in this, I have created a model which I told in the previous slides, like expected data in in first you can say from the opcode 000, it means add operation. Then 12 plus 34, it will create a expected data of 46, and what I get the actual 46. So both are equal, and also flag, for each flag I will pass on some expected flag data. That should be correct. That should be a golden output. So if I get that golden output as a same from my design, so I can assure that each and every operation is working correctly fine. So without seeing the waveform, I can see, and the print statement only we can see that it's passed, passed, passed. Likewise, uh, we have implemented a memory these are the specs for the memory. Data bit was 8-bit, address was 16-bit. So what memory does actually, read operation and write operation. Simply, when processor need to fetch data or instruction, it provides an address, right? And the control signal, whether I need to read, whether I need to write, and the data width is 8-bit. So this is the design. This is the RTL schematic actually, memory and the data output. It has some address data in, and these are the simulations. I have 16 bits, so 256 address width I have, total address, and 7-bit, sorry, 8-bit of data. So here we can see my memory is working fine. I have some location where I have done the read and write operations from the waveforms. So how we test the memory actually? My memory is working fine. How we can ensure properly with some checkers from waveform? It's very hard to debug. So here what I did, first statement you can see reset is working fine. Reset means what? We will put a reset. It means memory should not work. So what checker I did? First point you can see we drive some data at reset. When my reset is on, then I intentionally drive some data. Then my output is what? It should be 0, right? Because in reset it should not work. So if what I put in the checker, if my reset is on, I will drive my data, and expected output is 0. If I get the output as a data what I drive, it means reset is not working. So that we need to check. And what I will did, I have created a reference model for the memory where we pass on some whatever we write a data. Let's say 23 data I need to read. So we'll pass on the data to reference model, the 23, and what I get in the actual, that is also 23. Then I can say that my memory is actually working correctly. So for each of the data inputs, I'm getting some data for expected and actual. So another part was the instruction
Excuse
decoder.
me, Sachin.
Uh,
Sorry to interrupt you. This is just a
yeah.
gentle reminder that 2 minutes are left for your presentation.
Okay. Sure. We will move forward.
So speed up Dhruv now.
Yeah. So it's just an instruction decoder. If you just decode the instructions, we can move on the next. It has 3 states: fetch, decode, and execute. It will fetch instruction from the memory. It will decode what the instruction is, and it will execute. It is a non-pipeline. It will done sequentially. These are the opcode which map to some instructions. What I need to do. So moving on the next, these are the register what are implemented, and these are the simulation results. Here we need to check each and everything. So I have created a print statement there. From the next slide. Yeah, here also we can see here whole architecture is implemented with ALU results, memory width, everything is there, clock reset and instruction register and state and operands. So these are the print statements. So here we can see clearly at the 0 timestamp reset was there. So everything was 000 and XX by default. So for starting, yeah. So that was the whole result. So conclusion is to we have created the whole architecture. We have a mimic architecture with key components like ARU, memory, register. We have verified each and every module, then we have integrated, then again we have verified. And we have implemented a FSM and to this and at last we have this reference what we have taken from the paper and the websites. So yeah, thank you. Any
Hello?
question? Yeah,
Yes, sir. You have shown the RTL semantic, right?
yeah.
Semantic, right. So can you explain how this RTL view confirms that your Verilog code correctly implements the architecture and functionality of 8085 microprocessor?
Yeah, actually for that also we have created a test bench. What we say, we will give some inputs to the RTL on we expected, we some expect some data. So that if we get the that expected to the actual data, then we can confirm for the each inputs. Then we can confirm that our RTL and functionally it's correct.
What type of test
Yeah.
cases you have included in your test bench?
Yes, for there are many starting from reset that we will reset is working fine or not, then we will drive some data and we will pass on some expected in output there. And test case I can say for ALU it's a add every operation whatever ALU has, and
Oh,
for memory everything read write to write read write, and back to back read write and simultaneous read write. These are
so
the yeah.
you have handled the control signals, what you are saying that read, write, ALE, IO, during verification.
Yeah, we have two control actually.
Which two controls?
Uh,
Read,
Everything.
write.
Read write control
Okay,
basically.
okay,
Yeah.
fine. Okay, one more last question to you that do you find any limitation in your system? How you are
Lim-
going to improve it?
yeah, limitation actually we did not get much time to implement an interrupt, I will say. Interrupt
Okay,
signals are also there in the 8085. So that is
okay,
a whole different concept. There are many interrupts are there. So in future we can implement that also. There are
okay,
different types
and
of interrupts. Yeah.
okay. And the last question, which simulation tool did you use here?
Vivado for the schematics and the Questa Sim tool that is purposely for the verification.
Okay, okay.
Yeah.
So it's really a nice presentation from your end. Okay, I should
Okay.
appreciate it. Thank
Yeah.
you. Yeah.
Thank you very much, ma'am. Yeah.
Thank you, madam.
Yeah.
Okay, sir. Thank you.
Thank you for your presentation, Sachin and Dhruv. Up next, we have Onkar Poddar presenting their paper titled Failure Regions of QR Inventory Policies under Markov Modulated Demand, a Simulation Study.
Hi, good morning. Am I audible to you?
Yes, you're audible.
Am I audible, ma'am? Okay. So I'll share my screen. So I think my screen is also visible.
Not yet. Yes, it's visible.
Yeah, once again, good morning, everyone. Myself, Onkar Poddar. I am research scholar at Father Conseco Rodrigues College of Engineering, Mumbai, in Mechanical Engineering Department. My research is in uncertainty-driven supply chain is failure regions of QR inventory policies under Markov modulated demand. So this is a Marco and Monte Carlo simulation I have used. Now, QR inventory policy is how much quantity to order when the inventory quantity falls below a certain limit. So R is a reorder point. at a certain level the inventory is going to fall. So that is our point, and we order certain quantities, so we replenish that inventory, so that quantity is Q. So the idea of this paper is to check the failure regions or robustness of this QR policy. So this is not an optimization of a new QR policy, but for a identified or even for an optimized QR policy, how robust it is. So given the scenarios, so how much it is going to withstand. So those things we have identified in this paper. So so this is what I just put that given the scenarios, like what we are considering in this paper is instead of considering the demand as simply random, we are assuming the demand as that it has got some memory. Okay, so this I will explain it a little in further slides. So these are the gaps that we have identified from the literature review. So most of the literature review which I have referred, they are towards optimization of the inventory decision layers, or even at the supplier side or at the logistics side. They are the optimization. But when things are optimized, we also need to check at what conditions they are going to fail. So that is what something which I am exploring. And in the paper, we also compared this variations or uncertainty in the demand with the normal demand. So that gap has been shown in the later slides. So what we did is we model the demand using Markov chain. So instead of considering normal demand means random. It could be any normal demand. We are considering a demand where a situation is of some kind of three states, maybe low demand, normal demand, and high demand. So these three states we have considered, and with the Poisson distribution, then that is simulated. Run the QR recursion by Monte Carlo, and then map the failures. So the failure region F, this is the main thing in the paper. This will be there in the later slides. So the Markov chain that we are considering, the demands that we are considering is it has got memory. So let me explain it in simple words. For example, in the festival seasons or in some promotional events, when the demand is high, when the demand is too high today, it is most likely that tomorrow also the demand could be high. Or if the demand is low today, it is most likely that tomorrow also the demand could be low. So the demand has got memory. So it depends on the previous states. So this memory of the states is captured by the Markov. So for a three-state Markov matrix is defined like this. So rho is notation we use for a persistence value. As rho nears 1, it has got more memory. So more likely it is to stay in that state. If the demand is low, more likely it is to stay in the same state, and less likely to go in normal or high. So this we use as a matrix, and more it comes towards 0, and I mean, it will become random. It may go to high or low. It will shift immediately. So for the study, we are using 0.5, 0.7, 0.8, 0.95. Now, just to clear that the data or the numbers that are coming is a completely hypothetical case I'm using for this case study. These are the hypothetical data. Now, for a given case, I mean, for this study, we are using this, but how can one come to know what exactly this value to be used, 0.8 or 0.9? Now, this comes from the past data. We may take from historical data 4 years or 5 years. We will understand how is the demand, following the trend or pattern. From that, we can actually approximately find out the value of rho. That is the way. But for this study, I am considering different values just to study how things work for different values, and also for demands. I mean, we need to take certain values of demand. We need to draw some demand values. Those demand values I have represented as ratios. So high to low, like this I have considered. Lambda is that demand value, high demand and low demand. And we have tested it for this ratio, 2, 3, 4, 5. So 5 is most gap, 2 is very less gap between high and low. So like this, we have taken different values. Again, these are hypothetical values that I have chosen. And the calculation that we do, like the on hand stock, it cannot go negative. Either it could be zero or some value. So the previous day and plus whatever we have ordered, the arrival on that in the today, and the demand which is there. So that needs to be subtracted. This is the on hand stock and the back orders. Now back orders are the quantities which remain unmet demand. Suppose customer has ordered 1000, but at the inventory we have only 900. Though that 100 is the gap back order. So this is calculated this way. Then inventory position. This is the most important thing. Inventory position. So it is the on-hand inventory minus the back order. This is the committed order, back order, but it is there, back order, and plus the order plus the quantity that we have ordered. This is going to arrive depending upon the lead time. So today we have ordered, it may come after 3 days or 5 days. So this is the inventory position we calculate. And all these calculations run at the backend simulation day 1, day 2, day 3. How things are going to work for the complete 1 year or 2 years. Like this we have calculated. Then reorder trigger point. If the inventory position goes below R, so this is a QR policy. If it goes below R inventory position, then we will place an order size of Q like this. And the things that we are measuring is I am considering 3 KPIs here. One is the type 2 fill rate. Now, like what is the total shortfall divided by demand? If there are 100 shortfalls in out of 150, so like that 100 divided by 150. So we are considering some criteria. In most of the paper, they are using this beta around 0.95. So this is the trigger point. Mean back order. If the back order goes above 5, now again this 5 is a hypothetical data just to study this case. It could be 10 also in the next study like this. Then the maximum back order is also considered. Now it may happen that the average may be below 5. It could be below 5, but there could be case where only one instance the maximum back order is more than 50. And this is the failure criteria, the same thing. Service less than 0.95, back order goes above 5, and also this one. These are the three things. Now the total simulations, experimental design. So what we considered in this study is quantity to be ordered. We have to consider different values, 40, 60, 80, 100, like this, 4 parameter cells for Q. Then for reorder point also we have considered these 6, 10, 20. Then row values, as I said, we took these values. Then the demand, what we have taken, demand as in terms of ratios we have taken. So these are the 3. So if we multiply these numbers or quantities or instances, we get 384 parameter cell. Means if we try to find out the unique combination, we'll get 384 unique combination. And for one unique combination, we go for 20 replications per cell. Now this is because 1 divided by 20, it is 0.05. This is the confidence interval we get. So each set is done the same thing 20 times like this. And this it is run for 1200 days. So initial 200 is considered as warm up because we are assuming we are starting from somewhere. It may not be true. So let it run for 200 warm up, and the next rest 1000 is considered for actual decision making. And 3 KPIs are considered. So these were the results. Now this is the safe zone. This is the safe zone. Certain things we can consider from here.
Excuse me for
So
that, Omkar.
yeah, yes, ma'am.
Sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation.
Yeah. I'm done. So this is the safest zone. So as rho increases, this is more dangerous. Again, this is the safe zone plotted versus reorder point and beta. Now this is the failure map. Now this is the decision map which a manager or an engineer can look at it. So for a lead time 2, these are the safe zones. For lead time 3, these are the safe zones. So as the lead time is increasing, we are having more and more trouble. So this is something, a kind of understanding we get. Okay. So these are the understandings. So it may happen that even with the increasing only reorder point, the system may not be in safe zone like this. So for different again row values and ratios, we have this. So 60 was our reorder point. So if the ratio is 4 and 5, this demand ratio, means very high gap between high and low demand, then we need to go for higher value of reorder point. So these kind of instances we understand. Again, these are the plots we get. This is the safe zone above 95%. Now, this is a comparison study of Markov versus independently identical distribution, means normal, simply random without any memories. So, these were the comparisons like this. I will show it, I think, here only. Yeah, sorry. So, the more failure reasons are there when we consider demand has memory or those kind of things compared to IID. Yes, madam. These were the findings. The failure regions, it is more dangerous when we look at the lambda values, high to low, if that is more, and also the lead time. If the lead time is too much, it is more prone to fail that QR policy. Some other investigations must be done to control it like this. So persistence is the main driver. Persistence means the demand remains in the same state. Like for example, high demand, the demand remains in high state only. So that is the persistence. That is the main risk. So along with the lead time and persistence, it is more dangerous. So these were the findings. So that's it from my side. Thank you.
Hello, sir.
Yeah, yes, madam.
Why did you choose a Markov model instead of conventional stochastic demand model?
Because this is, madam, state dependent. Now, this is, I consider demand has got memory.
Okay.
So it depends upon the previous state. So, for example, we are running some promotional campaigns before Diwali or Christmas. It may
Mm-hmm.
happen that even after Diwali, there could be demand. So, to capture those memories, I'm using Marco, and Marco does it very nicely to capture those memories.
So, what do you mean by the failure regions in the context of QR inventory policies?
Failure regions means, I will just go to this map.
Hmm.
Failure regions means now for each cell we have simulated.
Okay.
Yeah, these are the failure regions, ma'am. If the fill rate goes below less than 0.95, I will consider that cell is a fail, even if the back order is maybe less than 5 or less than 50 maximum. Even one of the criteria is goes below the limit, that cell is considered as a failure. Even we might be having more than 95% fill rate, but if we occur an instance where the maximum back order in one instance, one simulation goes above 50, that will be considered as a failure cell.
So, according to your simulation results, under what demand conditions does the QR inventory policy fail? And what practical recommendations would you give to managers to avoid these failure regions?
Yes, madam. The overall study, it shows that when the demand values like high demand and low demand, when you compare from the past data, if that gap is too much, that gap is too huge, then
Yes.
lead time is very, very important. Lead time should be very small. It cannot go, I mean, beyond certain values depending upon their
What should be that
data.
lead time? Can you just give approximation?
Now, madam, for this particular hypothetical values or data, I'm showing it here lead time 2, 3, 4, and 5. So I'm
Okay.
showing that lead time should be 2 or 3. Now, it depends upon their products or service. And this is more generalized. So if we study it for a particular industry, then we can come to certain exact values.
Okay. So can this model be applied to real world industries such as retail or healthcare inventory management?
Yes, madam, definitely. This is my initial study in my PhD research,
Okay.
where most of the research paper are on optimization only. They come to a certain fixed value. But
Okay.
my research is how that fixed value is
Hmm.
safe enough. So that is my question mark. That is a research question which I'm doing. So right now, I have presented papers in conferences,
Hmm.
in two conferences using hypothetical data, and
Okay.
one paper I have put in Indus Science Journal where I have used a real data set, which is a Walmart data set. It was available in Kaggle. So
Okay.
that just also study I have done. So I will try to narrow it down to a specific industry and try to see
Sure,
how
sure.
things work.
That you should focus on.
Yes, yes, yes. Rather than more generalized.
Yes. Okay. Thank you so much, sir.
Yeah, thank you.
Thank you, Omkar, for your presentation. Now we have Ritu Patidar presenting their paper titled Multimodal Sentiment Analysis Using Transformer Models and Deep Learning Approach.
Thank you, ma'am. Please wait 2 minutes. Can I share my PPT?
Yes.
Ma'am, PPT is visible?
Yes, it's visible.
Good morning, ma'am. My name is Dr. Ritu Patidar. Today, I am presenting my research topic, which is based on multimodal sentiment analysis using transformer models and deep learning approaches, along with my colleague, Dr. Kirti Pandey and Dr. Upinder Singh. So these are the outlines of my research: abstract, introduction, types, transformer model, literature review, proposed experimental analysis, results, conclusion, and references. So nowadays, social media platform has a major medium to express the opinions in the form of images, text and visual. So in our proposed model, which is based on transformer based model, here we integrate the textual and image data, and we took a data set, MVSA data set, that is multi-view social analysis data set. And in our proposed work, it evaluates the performance using various parameters and compares several transformer models such as VIT, CNN, and RVM model to achieve the better accuracy as compared to our existing methods. So the problem statement is that in our traditional approach, we have used lexicon-based and rule-based method to analyze the opinion, and it is only text-based method. So nowadays, we are using the multimodal sentiment analysis to detect the human emotions by combining multiple data sources such as text, audio, visual, and facial expression. So it is based on natural language processing, and this figure shows the types of modalities such as feature level, decision level, and we are using transformer model also, and we are using cross model attention mechanism, and latest we are using the LLM model also in future. So these are the transformer model. First is the BERT model. It is basically bidirectional encoder technique, and it is especially used for text feature extraction. It captures the deep semantic meaning in the text, and it is a bidirectional in nature. Second one is the vision-based transformer. It is mainly used for image classification. Later, we have described in detail in our proposed method. Next one is the RNN model, and the next one is the CNN model. These are also for image feature extraction models. So these are the literature review. I have read many papers, and some are conference paper and some are renewed journal paper. So these are the latest research paper which I have read, and some are the from 2021 to 2023. And in our proposed methodology, we took a MVSA data set. These are the annotated data set, and the size of the data set is along 1.2 GB. It contains the 19600 data sample, contains the image along with the text data. So for image feature extraction, the input image goes to the DenseNet network. Here, it converts the feature vector into numerical vector space, and then it goes to the VIT, that is vision based transformer. Basically it works into the form of pages. First the image is divided into number of pages, and then we flatten the image by linear encoding method, and then this image goes to the positional encoding, where all the pages is matches to the image, and then it goes to the cross attention network. And on the other side, our textual data, it goes to the data pre-processing steps such as tokenization, lemmatization, stemming, and then after we calculate the term frequency of each word, how important the word in a particular sentence, and then it goes to the BERT model that is for further classification, and then both the output goes to the cross attention network where it is used to align and fuse the information from different modality. Here it is depend on the query key and value pair, and through this process we get the model evaluation and model classification in the form of positive, negative, and neutral sentiments. And for model evaluation we calculate a certain parameters such as accuracy, precision, recall. So this is our proposed method, and this is the experimental analysis. We took a particular packages and data set, and we took a MVSA data set. Here it contains the image and text samples. This graph shows the word count distribution across the density, where the positive words density is more as compared to neutral and negative sentiments. The word cloud shows the most frequently or most important words in a particular graph. So this is the positive tudes, neutral and negative tude word clouds. These are my result. As we compare our method with the existing methods such as CNN plus VIT, RBM, and our proposed method, we are combining these three transformer model and to achieve the better accuracy. So these are the parameter which I have mentioned in this table. These are the performance metrics, which shows the particular parameters by percentage wise. And finally, we conclude that we are using the transformer model in our work, but later we are using the LLM models to achieve the better accuracy, because the challenge in transformer model learning is extremely challenging and it requires the larger data set. Here we use the data set around 1.2 GB. So later we are using the LLM model to achieve the better accuracy. And in multimodal sentiment analysis goes beyond the text only approaches. So here we using the MVSA data set. In future we are using the multi-modalities to fuse visual along audio and other modalities we will use in later. So in future enhancement, we focused on understanding the vision language model for modalities of language and vision image. We further study various attention mechanisms and apply them on multilingual sentiment analysis to achieve the better accuracy and result. Thank you, ma'am.
Hello.
Yes, ma'am.
The first question, if one modality, text or image, is missing or noisy, how robust is your proposed model?
Actually, ma'am, we are using the transformer model. So
Which
after
transformer model you have used here?
vision-based transformer model.
Okay.
Yes, ma'am. And in vision-based transformer model, it goes to the several stages. First, our image is to remove the noise and all particular resize the images. We divide our image into the number of pages, and then this particular image goes to the linear embedding, which we flatten the image, and then we goes to the positional encoding. So it comes across the several steps. So here we also take the image pre-processing steps in order to remove the noise and resize our image.
Okay. So do you have the feature level fusion, decision level fusion?
uh, Ma'am, I have only idea, but I have not applied in our proposed work right now.
Okay. So if you can apply or if you can just study that, what are the feature level fusion, decision level, and cross model attention, okay? And which
Okay.
will be the best performance in your experiment if you will try. So you can at least go through and research it.
Sure, ma'am. I will try. Yes,
Yes.
ma'am, sure. Thank you for your suggestion, ma'am.
Yes. And what is your future scope? What will be your future scope?
Right now, ma'am,
Now?
I'm working on LLM models.
Okay.
How LLM models apply on sentiment analysis evaluation, because in transformer model the computational cost and efficiency is very high. It is very complicated process if we are using 2 to 3 transformer model for processing.
Acha.
So in future I will read some matlab, I have read some papers related to LLM model, how LLM model used in to detect the sentiment analysis.
Can your framework be extended to include video audio data for multimodal sentiment analysis?
Right now I have applied this work only textual and text plus image data.
Okay.
Further we expand other modalities such as visual plus audio, audio plus text. So,
Okay.
like that.
It's okay. Thank you so much.
Thank you so much, ma'am. Thank you.
Thank you, Rita, for that presentation. Now we have Meenakshi Kumar presenting the paper titled Transfer Learning Based Glaucoma Classification using MobileNet V2 and CNN Architectures on Color Fundus Images. Meenakshi Kumar, you may start your presentation. Meenakshi, are you here with us? Okay.
I think they have not joined.
Yes, ma'am. Rahul, you may start your presentation now.
Yes, sir.
Rahul will be presenting his paper titled Comparative Analysis of Machine Learning Models for Alzheimer's Disease Prediction Using Correlation-Based Feature Selection.
Is it visible on the screen?
Yes, Rahul, you are audible, but your voice is very muffled.
Front screen is visible.
Yes, it's visible.
Okay, good morning. I am Rahul. Today I will present a research work relating to the analysis of machine learning model for the algorithm disease prediction using correlation-based feature selection. In this study, we compare four
It
machine
is
learning
very
Can
models.
you
noisy,
hear
actually,
Rahul
not
clearly?
able to
Yeah.
listen.
Now, ma'am, audio is able.
Yes, yes.
In this study, we compare our four machine models to investigate the correlation-based feature on Alzheimer's disease prediction. And here's a table of content. First, we go through introduction and motivation. Then there is research gap and objective. After that, we read related work. Then about discuss about on data set description. Then proposed methodology. After that, the CFS correlation-based feature selection, then the result before and after applying CFS, and then compare results. After then conclusion, limitation, and future work. Alzheimer's disease is a progressive and neurodegenerative disorder and one of the major cause of dementia worldwide. It gradually affects memory, cognitive ability, and the capacity of the patient to perform normal daily activity. Traditionally, assessment commonly involve cognitive tests such as MMS and CDR together with clinical evaluation and neuroimaging techniques such as MRI, PET. However, these approaches may involve high cost, specialist expertise, and limited scalability. Machine learning provide a useful alternative because it can identify complex patterns and clinical and image drive data. Therefore, our motivation was to evaluate different machine learning model can effectively classify Alzheimer's disease status, whether feature selection can preserve or improve predictive performance. Then research gave several previous studies have applied machine learning Alzheimer's diseases to predict. However, many studies mainly focus on reporting performance of individual models or identify the best performing classifier. A comparative limited number of studies systematically evaluate multiple classifier both before and after feature selection under the same experiment of the framework. Therefore, our study have four objectives. Therefore, we have four objectives. First, we compare SVM, LR, RF, and NN. Then we apply CFS, correlation-based feature selection. Third, we compare predictive performance before and after feature selection. And then finally, evaluate all the model using accuracy, sensitivity, specificity, and AUC, area under curve. Here is the related work. Previously, study have reported promising result using different ML machine learning techniques. For example, Govardhan and colleagues report strong performance using LR and XGBoost, or Arjuna and colleagues evaluate multiple classifier, obtain approximately 90% of accuracy, and Alvarado and his colleagues reportedly around 86.84% of accuracy using random forest. And other studies have also reported strong using assembly learning, SVM, NN. Overall, the literature show that report performance varies depend on the dataset performance strategy, feature representation, evaluation protocol. For this research, we use the dataset from the OASIS longitudinal database. For the database contain 373 MRI session for the older adults in the age of range 60 to 96 years. The original dataset contain 15 features, include demographic, clinical, cognitivity, and MRI derived informations. The class distribution include 190 non-demented case, 146 demented case, and 37 converted case. Important variable include age, gender, social economic status, MMSE, mini mental state examination, CDR, clinical dimension rating, estimated total interaction volume, normalization brain volume NWBP, and Atlas scaling factor ASP. For our experiment analysis, the prediction problem was founded as a binary classification, distinguished non-demented case from the demented or converted cases. The proposed methodology, here we begin with the OSI longitudinal data set. Then the data set then under pre-process, including missing values, handling, and categorical encoding. After this, the feature engineering is performed to better represent the cognitive decline and longitudinal disease progressive. Then we have two conditions. First, the machine learning model are evaluate on the complete feature representation. After that, the second condition is CFS is applied on to reduce the feature subset. Both the condition of four models, same four model SVM, LR, NN are evaluated. Then final model performance is assessed using 10-fold K validation for every evaluation matrix. Then data processing is an important part of our framework. Missing value related social economic status, SES, were handled, while incomplete MEMS value were forwarded field, and single visit subject are excluded where longitudinal analysis required repeated observation, and categorical variables include gender, hardness were numerical encoded. We then create a binary target variable where non-demented case were represented as 0, while demanded and converted case were represented as 1. And additionally, then after that, reprocessing and feature engineering, we applied
Rahul.
CFS correlation-based feature selection known as the
Excuse me,
base.
Rahul. Sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation.
Okay, ma'am. The basic principle of CFS to identify the strongest feature to related the target class while weakly correlated with another, and the in simple term aim to retain a useful predictive information while reducing redundancy. And then result. Now I will discuss the result before feature selection. Both SVM and NN achieved the high reported accuracy of 0.987, and among the evaluated model, SVM demonstrated the strongest overall balance across the major evaluation metrics. Specifically, SVM achieved the accuracy of 0.987 and sensitivity 0.987. Specificity is 0.986 and the AUC is 1.000. The AUC value indicate excellent discriminative ability in the experimental setting. The neural network also show strong predictive performance, particularly in the term of classification of accuracy and specificity. Based on the combined evaluation metric, we identify SVM as the strongest overall baseline model before the feature selection. After the feature selection, applying CFS, we predict performance remain consistently high. Focusing on SVM, the model retain accuracy 0.987 and its sensitivity increased by 1.00, and meaning that all positive Alzheimer case were correctly identified with the report evaluation metric. And specificity is 0.927, which while AUC remain high 0.994. An important observation is that CFS did not produce a major improvement in overall accuracy. On the possible explanation is that original feature is set was already relatively small and contain highly informative clinic and image related variable. Therefore, the reducing of feature representation does not subsequently alter the performance. Then we have compared the before and after feature selection, where SVM accuracy remain exactly the same before and after. The sensitivity is improved and specificity is slightly decreased, and AUC changed 1 point from 00 to 0.994. Therefore, the main finding is not that CFS is dramatically increased accuracy. Instead, important observation is that reduce the feature representation was able to preserve very strong predictive performance. This suggests that SVM was stable and dimensionally reduction and remain the strong candidate for the Alzheimer disease classification. And last conclusion, to conclude this study, present a comparative analysis for machine learning for finding predict Alzheimer disease. SVM is among the strongest all over predictive before and after applying CFS. The accuracy remain 0.987 and sensitivity increase after the CFS is 1.00. The study indicate CFS did not subsequently change the already high predictive performance, probably because the original feature was relatively small and informative. However, our study also have limitations, like the analysis based on a single OSI, single longitudinal, with a limited sample size and broader, require external validations. In future work, we can validate our framework on largest data set like Adani, Explore, AI techniques, SAP, Lime to evaluate the advanced boosting and AutoML approaches, extend the framework toward the multimodal, multi-class Alzheimer disease analysis. Uh, Thank you, ma'am.
Hello.
Yes, ma'am.
Can you tell me that what are the features or which features you were selected by CFS and how many features were eliminated from the original data set?
Yes, ma'am.
Yes.
Ma'am, originally there is 15 features in the data set, and
Okay.
after applying CFS, there is only 9 feature left.
What were those features?
Ma'am,
Don't know.
right now, not ma'am.
Okay.
Actually, I am outside the station, so I have no paper right now.
Okay. So as you have compared with the different models, you have with SVM, logistic, regression, random forest, and neural network, right? So
Yes.
which model achieved the best AUC? Why do you think it performed with others?
Can you repeat my question?
You have compared with the different models, right? SVM, logistic regression, random forest, neural network.
Yes, ma'am.
So which model have achieved the best AUC?
NN, ma'am,
NN?
1.00 and SVM also both have, ma'am, 1.00 accuracy, AUC curve, ma'am.
And you have calculated the parameters of accuracy, sensitivity, specificity, and AUC. So did you evaluate the precision recall or do you have any thought of or no?
No, ma'am, at that time, no.
Okay, fine. One more question to you. If you
Yes.
were, if you have to extend your work, okay, so
Yes.
using the deep learning models such as CNN or transformers, so do you expect the feature selection to remain equally important?
Feature selection, maybe, yes, ma'am.
It is required, right?
Yes, ma'am.
And the model which you are going to implement that can be integrated into a clinical decision support system
Uh,
in the medical field, we can say healthcare.
Using these features, yes, ma'am, we can definitely integrate in the health system, ma'am.
Do you think that any challenges you can come across in the real time development?
Because, ma'am, I have implemented this model on the small data set and that are available on the Kaggle, and there's a limitation
Okay.
because the sample size is 373, and that's why I have not implemented on the largest data set. That's an also a issue, ma'am.
Okay. Okay. Thank you.
Thank you, ma'am.
Thank you for your presentation, Rahul. Now we have Kishore Babu presenting the paper titled Customized Crop Solution for Farmers Considering the Soil and the Climate. Kishore, you may start your presentation. Kishore, are you present in this session? Kishore, your screen is visible, but you are not audible. Dr. Suvarna, can you hear Kishore? Kishore, please start your presentation again. Due to technical difficulties, Kishore isn't able to share his presentation. So, Kishore, can you please join in the next technical session, 8E, at 11:30? We'll take your presentation there. And with that, we've come to the end of technical session 7E. I sincerely thank all our authors for the excellent presentations and valuable research contributions. I also thank all the participants for being a part of this session of the 11th International Conference on Information and Communications Technology for Sustainable Development, that is ICT4SD 2026. I hope you found today's session informative and enriching. On behalf of the entire organizing committee, we extend a heartfelt gratitude for your continued support, not only for the 11th edition, but also for all the previous editions. We look forward to welcoming you again at the 12th ICT4SD conference in 2027. All presenters will receive their digital certificates via email within 2 working days. The conference proceedings are expected to be published within 7 to 8 months. We kindly request your continued cooperation with the organizing team throughout the publication process. I would also like to express my sincere gratitude towards our session chair for effectively chairing this session. As a token of our appreciation, we present the certificate to you, Dr. Swarna. Ma'am, would you please like to share a few words to end this session?
Yes, ma'am. Thank you. Okay. Thank you to all presenters for their excellent research contribution and engaging presentation. I also appreciate the active participation and insightful discussion from the attendees. My sincere congratulations to the organizer GKRF and GR Solistic for successfully organizing this conference and providing a global platform that brings together researchers, academicians, and industry experts to advance the sustainable development through ICT. It has been a privilege to serve as a session chair. So once again, I congratulate all the authors and wish you continued success in your research endeavors. So thank you once again, and I wish everyone a successful and enriching conference. Thank you. Thank you, ma'am.
Thank you for your kind words, ma'am. We are truly honored to have you here with us. Now, before we end this session, I would like to request everyone to please turn on their cameras so that we can have a quick snapshot of this session. आई दूसरी लाइट ऑन कर जा पटकन. Okay. Thank you, everyone. I hope you have a great. Sorry. Can we stay back for a minute longer? Some more people have joined. We'll take another snapshot.
Thank you, ma'am. May I leave?
Yes, ma'am. Thank you. Thank you, everyone. Have a great day.
Thank you.